Welcome back to The Explainer. We are jumping right into Chapter 9 today, and honestly, this is where things get really fun. We're evolving from simple, basic data types to complex data organization by tackling one of the absolute most powerful features in C programming, structures.
Here is our agenda for today. We'll go from strings to structures, look at defining and initializing, check out structures in memory, scale up with arrays of structures, dive into pointers, arrows, and typedef, and finally do a recap and look at next steps.
Section 1. From strings to structures.
Okay, let's do a really quick recap of where we've been, because before we learn how to use structures, we kind of need to understand why they even exist. In Chapter 8, we learned all about strings and arrays. They're great, right? But they're rigid. A string only stores characters. An array of integers only holds integers. They only handle similar data. But real life doesn't work like that. Think about an employee. An employee doesn't just have one data type. They have an integer ID code, maybe a floating point salary, and a string of characters for their name. A standard array completely fails us here because it forces you into using a single data type. We need a way to group dissimilar data together.
Section 2. Defining and initializing structures.
To solve this mixed data problem, we introduce our new hero, the structure. By using the struct keyword followed by a name, like employee, we are literally creating a brand new custom data type. Inside the curly braces, we define the properties line by line. We've got an integer for their code, a float for their salary, and a character array for their name. Every single one of these individual pieces is called a member. Oh, and see that semicolon right after the closing brace? Do not forget that. It's a classic beginner trap.
So we have our blueprint. To bring it to life, we create a struct variable by typing struct employee e1. But how do we actually get the data inside of it? Well, we use the dot operator. It's literally just a period. By typing e1.code equals 100, we're reaching right into that structure and setting the ID. Typing e1.salary equals 71.22 targets the pay. The dot operator is your key to accessing and modifying specific members.
Now, using the dot operator line by line, that gets super tedious. Luckily, there's an initialization shortcut. In one clean line of code, you can type struct employee Harry equals, and then in curly braces, 100, 71.22, and Harry. Those values map perfectly to the integer, float, and string in the exact order you define them in the blueprint. You can even just put a single 0 inside those curly braces to instantly set all elements to 0. It's clean, it's fast, and it's going to save you so much time.
Section 3. Structures in memory.
Let's look under the hood for a second. How does the computer actually store all this mixed data on the hardware level? Well, what makes structures so incredibly efficient is their memory layout. Just like arrays, structures are stored in contiguous, back-to-back memory locations. So, say the integer 100 starts at memory address 78810. Because an integer takes 4 bytes, the float 71.22 takes the very next block, starting exactly at 78814. And the string follows right after that at 78818. They're tightly packed into one continuous block.
Section 4. Arrays of structures.
Managing one employee is a piece of cake. But what if you're building a massive database for a company with hundreds of employees? Creating individual variables for every single person would be an absolute nightmare. The solution? You scale up by creating an array of structures. You just declare an array, let's call it Facebook, that holds 100 employee structures. Then you just access them via index. So Facebook 0.code for the first employee, Facebook 1.code for the second, and so on. It keeps massive amounts of records perfectly organized. Real quick, if you have any questions or doubts about this, leave them in the comments. Your question might be answered in a future explainer. And if you're enjoying this series, don't forget to like and subscribe for upcoming chapters.
Section 5. Pointers, arrows, and typedef.
All right, let's look at some real C programming magic. We can point directly to the memory address of an entire structure using a structure pointer. You just declare a pointer variable with an asterisk, like struct employee asterisk PTR, and assign it the address of your structure using the ampersand symbol. Now your pointer is holding the exact starting address of that entire contiguous memory block.
There's a little catch, though. When you use a pointer, accessing the members gets kind of messy. The syntax *PTR inside parentheses .code technically works, but it's really clunky. Instead of dealing with all those parentheses and asterisks, C gives us the arrow operator. It's literally just a dash and a greater than sign. So you can just write PTR arrow code. It does the exact same thing but looks infinitely cleaner and more elegant.
And because a structure is treated as a single cohesive package, passing it to a function is super straightforward. First, you define your function prototype, like void show, passing in struct employee E. Then you call the function and hand it your structure variable. Boom! Execution! The function gets the whole package of mixed data and does all the heavy lifting, keeping your main code nice and uncluttered.
Finally, let's talk about the typed def keyword. Look, if you're writing code for complex numbers or bank accounts, typing out the words struct complex over and over again gets exhausting pretty fast. That's where type def comes in. It acts as a custom nickname. By wrapping your structure definition with type def at the start and placing a name like complex no at the end, you're basically telling the compiler, hey, whenever I type complex no, I mean this entire structure. From then on, you can just declare variables simply as complex no C1, C2. It's a lifesaver for keeping your code succinct.
Section 6. Recap and next steps.
We've covered a ton of ground today, so let's lock in your 5 key takeaways. Number 1, structures are how we manage mixed, dissimilar data under a single name. Number 2, you access those individual members using the dot operator. 3, under the hood, structures use a highly efficient, continuous memory layout. 4, when you're using structure pointers, rely on the arrow operator for cleaner code. And 5, the typedef keyword is your best friend for creating aliases and keeping your declarations clean.
But I want to leave you with one final, very important thought. Up to this point, all these massive arrays of employee structures we've built, they're stored in RAM, and RAM is volatile. That means the very second your program ends or your power cuts out, all that data vanishes completely. So how do we fix that? In the next chapter, we'll learn file handling in C and discover how programs can permanently store and retrieve data from files. You definitely won't want to miss that. Thanks for joining me for this explainer, and I'll see you in Chapter 10.